Hi there. In today's video, we'll be looking at some solutions to the labs that we've seen in our previous videos. And we'll be looking at the print function, literals, arithmetic operators, variable, data type, input function, and string operators. There are just about three of them, three labs, and I got some requests that we should treat them here on the video, in one of the videos here, so here we are. So the whole idea of the lab is just to get a proper understanding or get familiar with this concept. All right, so this is the very first lab where we are asked to format the output. I think this was from the print when we were treating the print function. It says that we should try to make this arrow twice as large, but keep the proportion, and also duplicate the arrow by placing both arrows side by side. Okay, I think this first one is quite simple, straightforward. It's just by creating more spaces in between. You're adding longer lengths and making the width wider. I think we should do this other one, whereby we should duplicate the arrow. All right, so by placing both arrows side by side. Okay, so jump right at it. All right, this is the very question. So if I should run this code. Yeah, so this is the particular code. This is the arrow here, and this is what generates it. All right, so there are several ways at which you can get our answer by placing them together on the sides by duplicating this arrow. All right, the first one I think we should just check is by either multiplying everything by 2, that is each line of code, you just multiply by 2, something like this. Yeah, I want to just say, sorry, outside here, and say multiplied by 2. So remember, in print function, in string operators, whenever you multiply a string, that string is multiplied, remember. So while we are multiplying by 2, it means that it should print everything, all of this string here, 2 times. And yeah, we'll see the output very soon. Multiplied by 2. Okay, I think we need more spaces here. Yeah, multiplied by 2 here too. Yeah. Alright, so multiply by 2, multiply by 2. So we need more spaces in here. We just need more spaces inside the string. Alright, so if I should save and run this. Yeah. So we got what we actually needed. We've duplicated this arrow side by side. Yeah, so this is very one exact way to try it, to do it. And I think another way you could do that is by not multiplying, by actually typing it out at coding. And what does that look like? It means something like this. Copy it from there and paste here. So this is where it gets interesting. You get to see how it looks like at the end of it all. See, I'm just copying and pasting, and sooner or later you notice that what I'm pasting on the right hand side is looking much alike like what we have on the left hand side. So this is at coding, just the same thing, just having to, instead of programmatically printing it out, we just type it out. So if I should save and run, you see, we get the exact same results. If you look at this, the function, the source code here, we have two arrows standing side by side. All right, so I think yeah, so it is left to you, and you could decide on which approach you like to use. Okay, so maybe before we move on, let me show you us one more step. So this other one more step is it's it's almost the same as this other guy where we're multiplying by two, but instead of doing this, instead of having everything scattered on multiple lines, so what we do is, if you notice the trend here, we just have the same print, and what we are printing is just this particular thing here. So instead of having to do this, we could just use the new line uh, character. So what do I mean by that? That means we could have just a single print function and separating everything by a new line character. So let me show us that by doing this. So we could use a single print function. So I don't need this. So I could just do this instead. Okay, so I could say comma. Now I have that out. Remember that the second line. So let me put another comma here. Remember the same code. This time I'm just putting everything on the same line and separating all with a comma. Actually, this, I don't know, it might be confusing to some people, but, and please don't try this. I am advising. So the whole idea of writing a code is for readability purposes, and if your code is not readable, then it is not a good code. So yeah, I want to use a separator, and I'll say my separator should be a new line. So by default, the separator is a space. It is an empty space. But now I want everything to be a new line. So what this means is that instead of adding a space to this place, when we are printing to the okay, let's just do that. So the default separator is a space. So if I should save and run this, you see everything is on a single line. But now what I want is I don't want a space. Instead, I want a new line as separator. So it means that instead of having a space here, it pushes everything here into a new line. Then at every comma, it pushes everything into a new line. So if I save this and run, voila, we have our arrow duplicated. All right, so let's, please you can pause the video, try to understand what is going on here. Okay, let me reformat this. This is just on a single line. Please note, it is just on a single line. And what we have on this single line is from the very first solution we had here, this multiplied. See? Yeah, just from here. When we multiply by 2, then I brought everything all together on a single line and separated everything with a new line. Yeah. So if I don't want to use a separator, if I want to just type everything, well, this is what I would have done. Yeah, so instead of that, I'll just add my new line inside here. But then what this will do is going to add an empty space, and which is not what we want. So the best way is just to add a new line at the end there. All right, so let's see the other one. I think we have, okay, this is the main lab. So we have lab one. So we have to complete the code for the expression below. Okay, this is the code that we want to complete. Okay, so let's get digging. Okay, so okay, when we have this sample input where we have x equals 1, so our expected output should be, our expected output for y should be this. So when our x is 10, our expected output should be this. All right, I think we'll get this. All right, so I think we can look at one or two ways of solving this particular expression. The first way I think I want to suggest is that we could break this down into levels, into smaller bits, such that this can be a part, this x plus 1 divided by x can be a part, then whatever answer you get here, let's say the answer is z, the next level will now be x plus 1 divided by z. All of this is now z. Now let's say the whole answer you get from here is now a, letter a, is now be x plus 1 over a. So we have that. So I think we can do that. So I think instead of using, I could use the word level. So this should be our level 1. Whatever we get here is our level 1. Then x plus 1 over level 1. Anything we get here will be level 2. Then everything we get here will be level 3. So that the final division will be 1 divided by level 3. Alright, let's try that first option out. And the other option is just to write the whole equation here as it is. That is 1 divided by x plus 1 divided by x plus like that in just a single on a single line. All right, so let's try the first one by breaking down everything into bits, into levels. All right, using this is the skeleton code we have to use. Okay, we don't need this anymore. Thank you. All right, so from our skeleton code, we have x equal float. And they ask us input, enter value for x, then write your code there. Okay, we don't need that. You just say print. Okay, I think I get that. All right, so let's continue. Input, enter value for x, then we say print y equals y, say y, oh y. Okay, yeah, so we have to write our code here now. All right, so we got the first and the last line. All right. So first off, if you notice this y is underlined yellow, meaning that we've not declared our variable. So I will just go ahead to declare the variable to be, something. So it's expecting us to put something. Like I said, we want to break everything into levels, so that this will be level 1, level 2, level 3. So let's do that. All right. So our level 1 will be something like, you know. So since this is level 1, that will be x plus 1 over x. So that's our level 1. X plus 1 over x. So I could leave it like this because remember from our basic operator, when we're learning operator, this in the precedence of operators, this comes first before plus. So definitely Python would treat this first before touching this. But just to be safe and just like I said, for readability purpose, we could just use our bracket just to ensure that this goes first, then whatever it gets comes adds up to x. So that's our level 1 and our level 2. Remember, these are level 1. Level 1. So our level 2 will be x plus 1 over level 1. X plus 1 over level 1. Alright, so I think we got that. So our level 2 will be x plus 1 over level 1. I think it's maybe interesting. But if you have any question, you can definitely drop. You could drop your question in the comment section. So x plus 1 over level 2. That's next guy. X plus 1 over level 2. Alright, so finally we need to so this is level 2 here. So sorry, this is level 3. Alright, so our final answer, this is level 1, this is level 1 here, this is level 2, and this is level 3. Alright, so our final answer will be y equals to 1 over level 3. Alright, so y, we have y here already, so call y equal to 1 over level 3. Alright. All right, let me just paste this for readability. All right, I believe. All right, let's use our test. So we said if we should input 1 as our x, we should get this value as our y. So let's see if we get that. I'm saving this and I'm running my code. So enter value for x, and I say 1, then enter. Great, I got, yeah, that was exactly, that's correct. All right, let me try 10. Let's see if we get this value. So I'm running my code again. 10, 724, 990, 990, 7294, 7294. Yeah, that's correct. Just to be sure, let's try 100 and minus 5. So I just need to run this again. 100 and minus 5. So for 114, 344. Yeah, 14 and 344. That's very correct. All right, so I said there are two ways. So now we've tried the levels and we could just write everything as a single, on a single line. So what do we do as a single line? We don't need this. All right, so if you'll be writing it on a single line, so you'll be having to do something like this. Let us use our parentheses as much as we could here. So I could start with 1 over, oh, sorry, before I do that, let me have this. Okay, so I get a picture of where I'm going. All right, so we have 1 over, which is this last level, the very last level, 1 over level 3 that we add. So but then, so we put every of our level 3 inside there. Okay, let me go back there. You see, so we have 1 over level 3. Now I want to bring everything together into just one single line. So what I do is just simplify every of these variables that we have here. So what is inside level 3? The whole of this, I'll put it here. That's what it means. So what's our level 3? That is x plus 1. Okay, let me just put that into a bracket. Say x x plus 1. Okay, let me open another bracket. No needed actually, but then plus 1, then we say level 2. Now I think so that's where we pick on that level 2. So what's inside our level 2 we open again here. So what's inside our level 2 is x, so let me just, because we're starting a new guy, x plus another 1. Yeah, x plus 1. So okay, open the bracket, 1 divided by level 1. So we still have something else. So what's in our level 1? So we are putting that there. So we open our bracket again and say x plus, open bracket, 1 over that, 1 over x. All right, so we don't need any of this anymore. Let me just comment that out. I save this and I run. Let's see if we get the same values. Vala 1, that's correct. 10, this is correct. 400, this is correct. And for minus 5, yeah. All right, so we're good. So we could use either by breaking down into levels or a single line, such as what we have here. All right, so finally the last, which is second lab. So this is said we have to complete the code. Okay, this is the code we are given. So we have to prepare a simple code to get when a time ends. Oh, yeah. So from a given period of time, which is going to be in hour and minutes, and hour can only be between 0 and 23, and minutes can only be between 0 and 59, obviously. That's very correct. So we have to complete this code. All right, I see we are running out of time. I really want this to be within 30 minutes max. All right, so we'll move to this third one. Okay, so hour equals to impute string starting time hour, starting time minutes, event duration delay. Okay, so let's type that out in our code. So we have r equals to int impute starting time, which is in hours. Then no column, and that should be it. Then we have our minute, and we have that is in integer. We ask it to impute the starting time. But this time in minutes. Yeah, so we space that. Then we have our duration to represent our duration, also an integer. Then we are imputing something from the console, and this time it is event duration in minutes. Okay, so what are we to do? We have this already, so we should just write our code. So these are our inputs and our output. All right. Okay. Okay. All right. So we have our used minutes and blah blah blah. All right. So we could just do something. Okay. So for this particular one, we would like to evaluate so many things. The very first thing is, I think, for now, don't let us take inputs from outside. Let me comment this out, and let me collect values in here by myself. I'm at coding. Let's see, the time is 12, and our duration is 15. So our next time should be 12:15. All right. So now I want to get the numbers of minutes that we've used. So I can say used minutes equals the number of which is duration plus the minutes, right? Yeah, there should be an S. Yeah, plus minutes. All right. So if I should print our used minutes, that should give me the total number of time I've used. All right. So let's see that. All right. So I've used 15 minutes really. Okay. So what if our duration is, let's say, 60? That is 1 hour. So if I should run this, our used minute is still 60. But then we don't want our used minute to be just 60. We want to pick the remainder, or in other words, the modulo. So what this means is that we want to pick for every time when it gets to, remember from the question, it says that whenever it gets to 59, it could only be between 0 and 59. So there should be a way to keep checking that whenever it gets to 59, it should not get to 60, instead go back to 0. So we want to keep that in check. So we'll be using modulo and 60, which is the cap number, meaning that we can't get to 60. Whenever it gets to a number before 60, go back to 0. So if I should run this, now that it's 60, it was showing 60 before, and I've changed to modulo, now it went back to 0. So if I change this to 65, so instead of showing 65, it should go back to 0 and start counting. Now we have 5. All right, so let's see. If we have 121, that should be 2 times. Then go back and start counting from 1. Exactly. All right, so I think we've cleared the minutes, counting minutes here, which is this guy. We've done that. So to count this, we'll use the same idea. But then we want to be able to count, when we use 120 here, 121 here, this is how many 60 we would get in 120. We'll get 2. This is definitely 2 hours and 1 minute. So we want to be able to count that. We want to identify the amount of hours used. So that means for every 60, how many integer numbers do we get? So we could use the integer division. That's where that comes in hour. So we can say our duration plus the minutes again. and let's put that. Okay, so let's do that division. Yeah, so this time we're using that. So what does this mean? Let me use accounts r. Let me run this. So you see, this is now showing 2. That means we've run 2 hours already. So if I change this back to 60 and I run this code, that's just 1 hour. Just 1 hour. If I change to 180, let me delete the one. So this is 3 hours. So let me see the amount of uh, minutes used and the amount of hours. So if I should run this again for 180, this means I've used 3 hours and 0 minutes. So if I change this to 84, 184, so that should be 3 hours and 4 minutes. Exactly, 3 hours and 4 minutes. You see, so far so good. We are just using the normal operators to build a time, uh, a real time watch, and yeah, so that is as simple as that. So we could, instead of this, so I think we've achieved most of what we needed to get. So just to be clear, let me uncomment this. All right, so just to be clear about what we've done, so we say that we are using uh, this remainder, the remainder operator, to ensure that our minutes, let's say, would be, so our minutes would only be between 0 and 59. Right. All right. So the same way we did that, but in this case now we will be using the integer division. So we use integer division to count how many minutes. That means how many 60 minutes was used. Right. All right. And so I think, oh, okay. So I think one more thing is, now that we've been able to count that amount of minutes, we need to add it back up into our hour so that we can present it to the user or the audience. Meaning that by the time we start from 12 o'clock, yeah, so we just say used hour. Used hour will just be the starting hour plus this count. If we are currently at 2 o'clock, if we are currently at 12 o'clock and we've used 2 hours, so we should now be at, the expected time should be 2 o'clock. 2 hours from 12 o'clock should be 2 o'clock. So we just add that together. So we add this 2 hours plus where we were, which is 12 o'clock, should give us 4 hours. So that's what we'll just be adding. So we'll be adding uh, our hour plus where we were plus where we are going, which should be, so where we're going, that's the count of our. All right. All right, but then please remember this, for the hours switch, it can't exceed 23, just between 0 and 23. So meaning we have to apply the same idea we did here. Let me put this in the parentheses, and so this will be in modulo, and remember 24 hours. So meaning it can't enter 24, it will be between 0 and the number before 24, which is 23. 0 and 23. This one too will be 0 and 59. So we could just mention that what we've done here. See, but now 0 to 23. Our hours would only be, yeah. So I think this is pretty much it. So we could just show our, our used hour, the end hour where we are, to be that. Then I can do this. then I can, yeah, use minutes. It's still fine. Yeah, so I think we're good. Okay, I don't want any space in between. I don't want any space in between. So if I should save this and run. All right, so let's try this. Our starting time, let's say we are starting 12:50, and we want to add 11 minutes to 12:50. All right. All right, so we have some test cases here that we can use. So if we are starting 12:17, then 59 minutes from 12:17 should give us 1:16. Let's try that out. So if I run this 12:17, 59 minutes from that should give us 1:16. That is correct. All right, so let's try 23, 11:58, 11 at night, 11 p.m. So 23:58, 6:42. 23:58, 6:42 should give us 10:40. All right, let's run that. So we have 23:58, 6:42, I believe. Should give us 10:40. That's correct. All right, so the last one is this guy from 01 to 29:39. Then it should give us 10. 01. So let's run this. So since at 12:01, then our numbers of hours is 2,939 hours, and you should get 101, which is very correct. All right, so I don't know. So if you have tried these labs on your own and it looks challenging, or probably you've even been able to solve some of them, but in another way, yes, it is good to see other methods. Yeah, and you should be proud of yourself if you've solved it another way. So from this class, we'll be moving on to the next part, which will be conditional statements, loops. We talk about breaks, continue, and some other more interesting stuff. It's going to get interesting the more. I think we are using more time already on this video. So we'll see you in the next class. Take 2 minutes. Thank you.